Yeah, I was saying I wanted to compare the two, the K3S and the Micro K8S, and they both are very easy to start up. I mean, you're always skeptical when you read an intro to anything that says, oh, it's super easy, a couple of lines and you're started in a minute. But the fact is that those claims are actually true. There's not much to it. And even on something as what I did was a Raspberry Pi 3B Plus, which is 2 gig of RAM. And it runs and still has plenty, well, not an enormous amount of space, but enough to run a container or two.
Maybe they're targeting the North American slot or something like that, so we can maybe, remind them.
Yeah.
Do you know how they actually run the containers in there? Because I've tried running containers with which access the host USB and which access the GPIOs. And I haven't tried this with Micro K8s. And depending on how they actually start the container, or they actually start the Docker container in there. I mean, Minikube uses some kind of VM magic in the background. Do you know how Micro K8 does it?
Well, both K3S and Micro K8s have you make a change from the default on the underlying Pi to get some access to get the container runtime to run the way it's supposed to. Mm-hmm. And I don't remember offhand. It's very prominent in the documentation of one of them and not so much in the other, but I can't remember which was which. And it just warns you that you might have issues if you don't flip that on. Then when it comes to accessing the IO, I'm not sure, what the limitations are on the OS letting you get through, whether you might have to run your containers privileged to get at what you need to get at the underlying hardware with it. I think it may depend on what you're trying to do, but running just an Nginx container worked for me. Mm-hmm. But I wasn't trying to use USB or the GPIO. I would think there must be a way to get it to work, but maybe you have to run it privileged, because it could be that only root is allowed to get to those things or something.
Yeah, so last time I checked, I had to run everything privileged, which might not be the smartest thing to do, but it works. So
yeah, I think a lot of systems presume that if you're getting direct access to the hardware, it ought to be a privileged operation. Granted, there might not be a way to steal information out of another container by getting at the GPIO, but there are a lot of hardware things that just random addresses where you could pierce security boundaries. So maybe as a default, they lock down everything. I don't know.
Yeah.
I think for an edge application, I'm not sure how likely it is that you're going to run a lot of pods and that those pods are going to be multi-tenant, where that would be a huge concern of a breach from one pod to another.
Yeah, that's a problem. And also, I don't know have you tried to do a long running K3S or Micro Edge about that? Because my friend just ran it and let me know the K3S it's running for a while when the API server have a cache. So it's not like they claim there's only used a few megabytes or less than 100 megabytes. It's grow really fast, go to 300, 400 megabytes memory consumption. So I haven't tried that myself yet, so I will give it a try.
Yeah, maybe they have some kind of garbage collection going on too, where it would come back if you needed it. But
yeah.
no, I haven't. Mine's been running I haven't checked it this evening because I've been away on a trip, but it was running at least a week.
Mhm.
And it didn't crash or anything is about all I can say, but I didn't go back to check for growing memory usage or anything like that.
Mhm.
Grafana dashboard.
Yeah. In fairness, I'm not sure that either of those claims to be a full production ready release yet. Maybe they do, but a lot of those things have, you know, version levels that are below 1.0, implying that maybe they're still in the development stage. So maybe some of those things are still subject to improvement as it gets better.
Mm-hmm. So yeah, I briefly talked to Sean from Rancher in during the KubeCon.
Mm-hmm.
He told me they already have 1 million deployment for the K3S. However, the majority is using the the K3S as a more like a resource management on the edge side instead of the whole control plane, the cloud edge, the hierarchy architecture.
I don't even know how would they measure that. I mean, is this like licensed customers or because
I think
otherwise,
so.
since
I've heard,
people can just download it, I don't know how you'd count them other than.
I don't know how I haven't got a chance to talk to him in detail, but I will try to find him. But he claimed, I think Chick-fil-A is using their K3S to manage their edge side. So I am really interested to see what's the user case and how they leverage this and how they basically how in production they use that. The purpose is right, more like a cloud edge, this architecture to use the cloud overshadow all the edge side, or just use a or more like independent edge management, because they claim a few users have a couple of small machines. So basically it's a standalone machine. They just deploy K3S so they can run it more like a PaaS platform, so they can deploy application and do the application management on the edge side. I think it's a good use of the K3S. I just don't know that the main purpose of that, or
Yeah, I'd be curious if they're willing, if they have stats and they're willing to disclose them, even what the figures are for running on ARM versus x86. And I know that I've seen an awful lot of bloggers writing about using K3S just as a personal home lab, you know, to learn Kubernetes because it's small. So if you're trying to do this at home, don't have much resource. I know I've got a lot of coworkers who have just stood up a cluster with Raspberry Pis just because it's so inexpensive and it actually gives you a real cluster that you just leave around and build very inexpensively. People are using those even for home automation projects. So I wonder.
Yeah, that's likely their purpose, and more like running independently, right? Individually have a platform, or I don't know how they compete with Minikube. I think it's probably much smaller than Minikube, and maybe they have potential to make a cluster, different K3S to form a cluster or to manage that. Or yeah, I need to do more research on this.
It was kind of interesting. I met one of the Google people that supports Minikube, and they actually had some ability to detect the type of operating system being used to download Minikube, and were surprised that a slight majority were coming from Windows boxes rather than Linux. That you know, that might just imply that it was developers who happened to be running Windows and, you know, using Minikube to do test and dev on their local computer or laptop.
Yeah, that's definitely Kubernetes getting into the mainstream, right?
Yeah.
But isn't it like installed with Docker anyways?
Yeah, it is. So there, you can, if you put, I think, Docker desktop or something, run it
Docker
fine.
for Windows.
I think, you know, in the US, a lot of the developers are running Macs, but I've heard that in much of the world that flips over to where Windows is more popular.
Yeah, I saw the news. A few German government used to use the Linux. They are flipped to using Windows right now. That's a two local government to do that.
I think in China, Windows is far more popular than MacBooks too, right?
I think it depends on the community, right? In a developer, it's more and more standard. You have a MacBook or MacBook Pro with the external monitor. It's
Uh-huh.
like that. But however, it's the regular people. Maybe Windows is more popular.
I think also there's maybe a bias in California. You see an awful lot of MacBooks. It's not the case in, Chicago.
Yeah. But by the way, I got the new 16-inch one. It's really nice.
Right. Speaking of which, I think, we're all probably fans, but I've noticed that when I've been doing workshops for edge computing and stuff like IOFOG workshops, at least 50% of the crowd turns up with Windows.
Yeah, and don't assume
these are quote unquote
I'm a
developers.
Mac fan here. I'm not. Now, it might not be conventional reasons. And I've got a coworker who just flipped over to running, I think he's running his MacBook on Linux. But I chose what nominally is a Windows box just because you can get it with more RAM.
That's true. So on the topic of pulling down Minikube, right, on Windows, I think people, from what I've seen anyway, want a local environment that translates over to where they're going to be doing production stuff, but they want to take it with them as they go. And that's one of the things that we do with IOFOG is let you stand up like all of the whole environment right on your laptop, right, whether it be Windows or whatever. And I think, this is not the first time I've heard somebody say that, Minikube for them represents kind of like, the work that they're doing, how it would translate over to a bigger system. So not too surprising, actually.
Yeah, now, even though my base OS is Windows, I actually run a hypervisor on it. So when I do my Kubernetes work, it's inside a Linux VM.
Well, said like the true VMware team member.
I think, yeah, the thing is that, yeah, most devs want to have a local environment, especially like if you need regularly to build and push a lot of images. So having something, yeah.
Well, Dan, this is the topic you've been bringing up a lot lately, which is the developer experience, right, for building for not just the edge, but building for a Kubernetes-driven cloud, right?
Yeah. And I still don't see it being like a solved properly for every use case. I still, basically struggle with it on a daily basis, going back and forth, trying these different things. On some end, you would like to have it locally and like, your kind of ID experience, so you can, run things quickly and reiterate over your code quickly. But on the other hand, these systems, are becoming too big to be run even on a more powerful laptops. It's still a pain. So I got a new like a 15-inch MacBook Pro, and this is the first time it's a step back, but and one of the things, it's overheating constantly. Like if you try to run something on it, it will just scream.
Yeah, my own belief is those super thin laptops, because I used to be a hardware designer, and they just can't get decent cooling. So those really skinny ones, I contend, especially when they put an i7 in them, that they'll run at that high speed for about 2 minutes max, and then they'll thermal downrate. And you don't really get the speed. And I think they're just glamour items for an executive to show off. And no developer should be on one of those skinny ones. I mean, the physics of a fan in that thin form factor just don't work out.
Yeah.
Yeah.
I mean,
So
you can
average.
SSH out directly, right?
What's that?
You can just use it as an SSH hop, and
Yeah.
that's it.
Right. Right.
But if you
I
go
just
to the
realized
bigger ones, I don't want to name the brand name I'm on to plug it, but I'm, there's one vendor that has a workstation line of laptops. I made the mistake, I get to refresh it every few years, and the one now I'm on sort of the mid-range, like 15-inch, but they have a 17-inch that can now go to at least 256 gig of RAM, 3 hard disks, and you can put Xeon chips in them if you want to. And the trouble is the thing was just such a power pig, and 17-inch screen was unusable in an airplane. Even if the power supply also made it unusable. I remember plugging it in and taking out my whole row of seats when it flipped the breaker, because it's a laptop but has a 260 watt power supply. But that thing is a rack mount server in a box. And even if you go down a notch, you can still get these 15 inches that go 64 gig or 128. And I don't think you have any pains with building much of anything on something like that.
right. Can we, are you guys interested in talking about like the developer experience for IoT and edge stuff with relation to like the data streams and the environments that you wish you could test in, but are never going to be available on a laptop, such as you would like to, you paste into the chat your laptop?
No, this is, while I thought of it, I came across a nice blog article. It was written in
Cool.
December, apparently. It covers not necessarily developer experience, but the app. A lot of these talks about Edge don't address, they talk about landing Kubernetes there, but not the whole CI/CD workflow,
Mhm.
building container images, getting them out there, using the CI/CD.
Cool.
And one of the things, Dion, you just mentioned that your build tools are tough to fit in your laptop, but one of the things in this article was the point that it was important to minimize the size of your container images. And you don't,
Absolutely.
without putting some thought into that, that doesn't just happen by itself necessarily. And I'd like to talk about what the, techniques or tooling is to ensure that your container images are as small as they can be, because, you pay the cost. If I've got 100,000 inch locations, I got to pay for the bandwidth to get those things there and the time for them to get updated when they get replaced. And that's an interesting topic. I think that's potentially a topic Cindy has proposed talking about app life cycle for our maintainer track session at KubeCon Europe, but that would be a nice couple of slides to talk about at that session. Anybody have any thoughts on that? And by the way, that blog post I put in the chat, but if you guys didn't find it on your own before, I thought it was a pretty nice article.
Yeah, I love the topic.
Very interesting.
Yeah. And I try to scratch it, a little bit in San Diego, but I think that there's a lot more we can do there.
Yeah.
That's for
Well,
sure.
I mean, if you look at that article, it's really long. And I think that there's more in there than you could put in a 35-minute presentation if you covered all the topics in that blog. It's actually, I think, typical of blog posts where I feel that in a longish blog, you can cover a lot more than you would in a presentation.
It's a good one when it starts with a too long didn't read summary.
Well, actually, it's like, if you read that, it's like an attempt at seriously putting things into production at a really large scale too, as opposed to a lot of these things are about some little prototype effort.
Yeah.
And the definition of edge for this writer is not quite like, I wouldn't call it device edge, but by any stretch. To them, edge is landing things in public clouds all over the world, but I think a lot of the principles being talked about apply.
Yeah, I think from the application development, it doesn't change that much. You know, if you're going to run a cluster on the edge or device on the edge, the question is how you're going to keep developing that software and push it there. Yeah. So Moritz, I don't want to put you in the hot spot, but this a little bit crosses with what we talked a little bit about the past couple of days. So
Yeah.
wanna bring it up to this group? Or
Yes, sure, we can do that. Let me just open that.
So in nutshell, Moritz started considering a new white paper that we talked a little bit about Kubernetes architectures on the edge and started laying that down. And then exactly this topic popped up where I said maybe we can extend the white paper and talk a little bit about the developer experience. So that's where we are.
Do we have a working draft of this white paper ready to share yet, or?
I'm not quite sure if it's ready to share, but let me give you a quick rundown.
Yeah, I don't want to rush you, but if it is,
Yeah.
whenever it's ready, let me know. I'm interested.
All right. So can you see it?
Yeah.
Yes.
Okay, perfect. So yeah, basically the basic idea of this document was, or we had in our research project, was to get like a broad overview on different architectures on the edge. So because right now I think there's like a lot of different a lot of hype around the edge, but nobody really knows what it's really about. Like, how do I actually build systems with Kubernetes on the edge or with containers on the edge? The basic idea was to give like an overview on different integration strategies and edge of edge devices and different edge architectures. I just copied the stuff from James Kirkland, which he talked about in his last meeting. And my ultimate goal right now would be something like this in the end, that you have like the different architectures on the right, and then you have like flexibility, performance, security, robustness, and so on.
Oh, that's an interesting, yeah, I like that.
As a quick overview on top of the different architectures, that of course, if you are starting to implement new architectures or new products, that you kind of pick your architecture that you want to go with, because maybe when you just do like small, I don't know, IoT edge devices which just, I don't know, read the temperature, you want to go fast, flexible, and security might not be the biggest concern for you, while other applications might be super critical. So yeah, I just got started over the Christmas holidays, sent it around to James Kirkland, to John Kilton, and a few colleagues of mine, and we got started talking a little bit on it. And I think John, you suggested that we might broaden up the whole thing, right? Which I find a fantastic idea. So we kind of go away from just Kubernetes and maybe go more on architectures on the edge. One of my ideas was to maybe split it into two working papers that we do. Okay, we do like more the theoretical stuff on architectures in one paper, and then more like a hands-on guide in another one, where we actually pull in different projects and different different projects and say, okay, this is a use case for this project, and this is a use case for this architecture, and so on.
Yes. So just to explain my thinking. So when I saw that you're mentioning operators and pub subs, I my brain clicked and said maybe we can add this, but giving it an afterthought, I thought maybe it's actually two papers. So one on the Kubernetes architectures, and other is on the cloud native, edge native application development. So we might start with what you had in mind, see how long it is, and can it stand by itself, and then.
So can you scroll it up and let me see the edge architectures that you've got so far? So
yeah, I just dumped everything in there, what was on my head, basically, and I think you also added something else, right? GitOps and
No. Yeah, I just added a comment that we can maybe talk about it as well. Yeah, but
yeah, GitOps and yeah.
What's interesting about these is that they're not theoretical or hypothetical, right? These are patterns that have emerged, and none of them have disappeared, telling that there's something valuable about each one of these. I definitely have my favorites, but they're all alive and kicking at the moment. So I find that very interesting and definitely worth documenting the way that you've structured it. I know it came from the what James first presented, and then you're expanding on it, but I think this breakdown is going to be really helpful for everybody to see how on earth do I use Kubernetes in tandem with or at the edge directly.
Yeah.
I hope to get in and make some contributions here. I didn't get a chance yet, Moritz, but I'm really glad.
All right.
Yeah, so James and I submitted a session for KubeCon EU on this topic. So I think we can work on it here, basically. Yeah, it's over easiest to get the slides from the white paper than the other way around, right?
Yeah, totally. Actually, and then you can always point people to the white paper for more.
Exactly.
Well, but do you think that that's a deadline, Moritz, that you can feel comfortable with, is having it?
Well, this is just a proposal. I don't.
When is KubeCon? May?
It's end of March. It's the last week of March, and
March, yeah.
I think leaks into the very beginning of April, if I'm not mistaken. And then the other issue is I didn't pay attention to when they're supposed to get notifications out, but a lot of us procrastinators don't actually fully commit to the presentation until you get the notice that the talk was accepted. You might have good, noble ambitions, but there's usually disruptions at work that give you an excuse not to actually get started until you know you need to.
I mean, March could work. Should be
and I'm not trying to put pressure on. I know
that's all right.
It was helpful for the security one for us to say like, okay, we're going to try to get it done by a certain date, and then it slipped a couple times, but it really helped to keep asking everyone to contribute by a certain date.
Yeah.
You know, the other good thing about getting a bit of a rush on these is this field changes so rapidly that if you wait too long, what you thought you had finished might have to get done over.
Just changes too fast. And we can definitely, even if James's session isn't accepted, we can definitely at least mention it at the working group session, right?
Yeah.
And get more eyes on it.
Yeah. I mean, I'm not like the super expert on every architecture, so if you just like leave me little hints in there, I can try to like get a little bit more review on literature and everything else. Of course, coming from an academic standpoint, that's what we normally do, and I'm quite good at that. So we can definitely do that. So just trying to get like a broad overview on all architectures, and then we can like pick the different ones and maybe try to get a nice paper together.
Yeah, I mean, I can't say that this list is wrong, but another way to approach it is just to go at the number of nodes. You know, you start with 0 Kubernetes worker nodes. In other words, that maybe the control plane is just managing something that's less than a worker node, like just a runtime that's on some box, but not claiming to be a worker node, up to single worker node and cluster. I mean, it pretty much has to be one of those 3 things, right? And then to the extent there are worker nodes, they could vary in size, but 0, 1, or more than 1 seems to be a fundamental classification that you can't argue with.
Yeah. So you would say that like 1 would be, I'm just running Kubernetes on one edge device, for
In other words, at each edge location, I only have 1 node.
Okay. Yeah.
Yeah, single node cluster, right, where the Kubernetes is on the edge itself. Yeah.
And a 0 node might sound bizarre, but my contention there is you've done something like you're using the Kubernetes control plane with a CRD or something, and or to manage a containerized workload that is technically not running on a worker node, in that maybe it doesn't have kubelet at all. It isn't using the Kubernetes scheduler. Some of those things in your list, like virtual kubelet and CRDs, are maybe a means to implementing one of those classes and not really a fundamental distinction. They're just a choice of how you would go build out a 0 node, a 1 node, rather than, you know, an architectural classification by themselves. But I'm just brainstorming here.
No, I think it's making sense, actually. I think
I think this.
Yeah. Sorry, Moritz, go ahead.
The thing we just copied here, like the more I read over it, it's like basically 2 things, because we have basically virtual kubelet, micro K8s, and small K8s install, which are basically on how to manage Kubernetes. And then we have CRD based agents, and which in my understanding are more like an architectural pattern. And then we have full K8s install, which is again K8s on the edge. So we might need to pull this one out.
Yeah, I mean, small K8s and full K8s, they're both K8s, so.
Yeah.
And if you have small, large, you also have medium, so it's a continuum. It probably calls for a taxonomy where it's just very clear that it falls into one of these 3 pigeonholes, and then it's a different access in terms of how you best build out one of those 3 classes. But
yeah.
What I guess we'll probably want to mention too then is what federation looks like right across wherever Kubernetes is at the edge. Otherwise, you're talking about basically an on-premise control system. Not how to do it rather, but just that right, that there's the architectural approach is requiring federation if the edge nodes are in fact their own clusters.
Yeah, it's sort of, to some people, edge means lots of them rather than where they're located. To others, edge is that has to do with the geographical location. But once you get to hundreds, thousands of them, if you are using full Kubernetes rather than just worker nodes at the edge, then federation of how you manage thousands of instances of Kubernetes cluster is arguably an unsolved problem, although there are vendors who maybe contend that they are working on or have solutions. But
especially if
I don't know if anybody, well, maybe they're out there, but anybody heard of somebody who contends they've got like 5,000 Kubernetes clusters in production?
Yeah, we have the stress test for that. but we haven't have a real production deployment.
Mhm.
I heard that some company have about 3,000 in production, each cluster.
I mean, there might conceivably be people using Kubernetes at edge air-gapped so that they can't federate them and maybe don't want to just because they have no connectivity. I mean, I think it would be valid if you sold some product that happened to have a Kubernetes cluster embedded and had no need to connect to the outside world. There's no rule that says you couldn't build that, but so perhaps there are people with thousands of clusters that don't have any interest in federating.
Yeah, and in that case, I would argue that those each cluster is an independent case, right? Because and thousands of clusters doesn't matter. Each one's isolated. But industrial automation is probably one of those cases. Yeah.
Yeah. I mean, whether they know it or not, they still have a need, given the number of lines of code in a Kubernetes cluster, to do updates on it somehow. And I would want that update process, if possible, to be updated. But if they don't have external connectivity, I guess it's just a lifestyle choice.
So, Moritz, what can we do to help you get this paper advanced? It sounds like we just gave you some real-time notes.
Yeah. Maybe just give me comments and give me as many architectures as you know. Like, just put everything in there, and then I will try to put all the things together and then draft some written stuff out of that. Give comments on the architectures I already put down. If they're right, if they're wrong, I don't care. Like comment your heart out, basically.
Okay, cool. I will find some time to be able to chip in on that. So you might just see all of a sudden one evening, a bunch of notes and then nothing again from me for a little bit. But
perfect.
You know, an interesting thing, I'm getting back around to how you do apps out at edge locations, but if anybody comes across any interesting blog posts or articles or talks on running functionless out at edge, I'm kind of interested in the subject. You know, a lot of people talk about getting container images out there and running a containerized app, but suppose I want to run my own Lambda out at edge. What's out there to support that?
Other than AWS Greengrass, I don't know, and I'm actually interested in the same topic. So I would love to also be privy to that.
I mean, you know, it'd be a great talk, but unfortunately I'm trying to learn about it. So it's hard to have a talk when you don't even know the subject yet, but.
So how about the Agile IoT? They have the similar to Greengrass.
Cool. Are they open about how it's implemented?
I don't think so. Yep.
Yeah, if it's a black box proprietary, it's tough to learn other than. But Kilton, if you, maybe it sounds like neither one of us is a subject matter expert at this time, but if you wanted to have an organized learning activity directed to give some joint presentation at some conference in the future, I'd be up for it.
Yeah, that's the way to do it. Best way to learn something is to first agree to teach it and then go and scramble it together.
And then let the fear of embarrassment in public motivate you to go learn about it.
That's right. I mean, that's how I got started with Docker way back in 2013. I agreed to tell somebody about it. In all seriousness, you know, I'm road mapping like what we're going to add into IOFOG runtimes, and we got to add serverless because we've got demand for it, and I've got to figure this out. So I'm happy to dive in with you, Steve.
I did hear a complaint at there was a pre-conference called Rejects at KubeCon North America, and at the Rejects conference, somebody in a hallway conversation, it wasn't even a presentation, but we had an interesting discussion, about the startup time. So it was the person associated with OpenFaaS, which is a way to get functionless running on Kubernetes, and I think potentially on non-Kubernetes platforms, but complaining about how the transition from 0 instances to 1 actually has a big startup penalty on Kubernetes. And, the comment by one of the architects of Kubernetes is that, when we design these control loops in Kubernetes, if you make a declarative statement that you want 1 instance of this container, if it took a second to start that out, that's going to pass all the test cases we have. And yet, if this is a function call that you'd expect to take 10 milliseconds, 100 milliseconds, having it be so unpredictable that if it happened to go quiet, so there's no backend services running and it suddenly takes several seconds versus 100 milliseconds, it's tough to call. One of the measures of production worthiness is the behavior is predictable, and it becomes unpredictable. And the hallway conversation is that at this point in time, hosting serverless on Kubernetes, that might just be something you have to live with, because if the act of bringing up your serverless backend requires instantiation of a pod running somewhere, there's no guarantee, short of never letting it get to 0, that it's going to predict.
It's like if your serverless infrastructure is deployed as a container, then it's not really what we're aiming for here, right?
Well, I don't know. Do you suppose that in some of these clouds where they have these functions that they aren't actually running in containers then? Like,
I wouldn't be surprised, but I mean, so there's the Firecracker VM, right? Which I think that's what it's called, right? Which was, I think that's the basis of the AWS Lambdas, if I'm not mistaken. Fact check me on that, please.
I don't know.
Video, but different ways of encapsulating your serverless function environment, right? I would think that if you are going to host a serverless environment for dynamically, scaling up, down, you would want that infrastructure to, as you said, remain at a count of 1 or greater, so that you don't have the startup time of the engine itself. It's like, I'm not going to wait for the OS to boot to start the application if the OS is supposed to be always online waiting for me to, to start up an app.
Mm-hmm.
That was my always concern, thinking about this, like, on the edge, if you're dealing with the limited resources.
Yeah, the trouble is at edge, it's more costly to always keep the one running, right?
Yeah. So the cost of keeping the serverless infra versus the cost of scaling actually the service down. If that's the only benefit, I'm not sure. Yeah, in which use cases it actually makes sense. Yeah, it's a completely different story than the cloud serverless, right?
But yeah, I can't think of a secret solution. I mean, you said that maybe you've got Firecracker VMs, but suppose you're at edge, the distinction between VM versus container, well, probably containers better because they're likely to have faster startup, right?
Yeah, I would think so. I mean, I'm actually going to
eliminate the OS boot at least.
Yeah, I'm going to actually find out what maybe the right approach is for like an IoT gateway. If you're going to offer serverless on it and also have, a container environment, and also making those things play nicely together.
But I mean, for some consumers, the way they were sold on serverless is that if there's 0 use, there's 0 cost. But if you always are staging 1 and it's your own equipment, which I think at edge might be a fair statement, it is never new. 0 cost. So is it really serverless by whatever you call the definition of it?
It reminds me of the fuel saving and, emission saving trick now that a lot of automobiles use, which is that the engine turns off when you're stopped at a red light, right? Mm-hmm. And then, you can't drag race anymore. It'll start right up as soon as the light turns green, and you're not really missing except maybe a half a second, right? But you can't drag race anymore, and it depends on what your use case is.
Well, the interesting thing is if I made a car, I might be able to get away with some prediction, because suppose they put a camera there and you're watching the traffic light in the other direction and you see it turn yellow. So you get advance warning that you're about to get a green
Yeah.
and you start it. I mean, that might actually be a desirable feature for one of those cars. But unfortunately, with function as a service, I'm not sure that it's almost like there must be some math proof that would say that you can't anticipate in the future that somebody is going to call this function. It's sort
Exactly.
of like
You would need,
one
by
of
the
the
time the
things-
control plane sends a signal saying get the infrastructure ready, it might as well tell you what to start up, you know? So
Yeah, if you could actually do it, it sounds like it would be another form of like Spectre or something where you're doing speculative.
yeah.
It's sort of like speculative execution where somebody's about to call, or I predict they're about to call this, and
Yeah.
would that even leak information?
We'll have quantum communication, which is near instantaneous for the infrastructure, and then regular communication for the control plane call. How's that?
I
No,
see
it
nothing
could
that
be
can
in
go
some
wrong there.
algorithms. They could predict that they're
Like
they're
Kubernetes.
likely or certain to call this, so they could go from 0 to 1 with advance warning, but I don't think you could generically assume that.
Yeah, I'm thinking that all with all seriousness, I'm thinking that probably having the serverless infrastructure at the ready, if you're really going to be changing workloads quickly, just bearing the cost of having that infrastructure sitting there and consuming resources ready to take on jobs. That's what I'm assuming, but I'm going to find out as we dive into it. So
I wonder if there's any container equivalent of swap, like with memory, where you
Mhm.
roll the thing out of primary resource consumption so that you're not so concerned about it.
That's interesting. How can we make the frozen dinner version here, right? To basically bake it, get it ready, have it just isolated, frozen, and then just thaw it real quick. Yeah, I like this. It's interesting. Well, Steve, I'll commit to finding out more about this and sharing with you, and we can maybe present to the group here after we look into this. Everyone's welcome to chip in, and thanks, Moritz, for posting the link there.
Yeah, exactly. I tried this
it's
out a few weeks ago. Worked quite nicely. I think it's from Vietnam. Yeah. And you're basically up and running in like 5 minutes. So you just download a pod and then you're good to go. I think they run the functions in a container. So yeah.
Cool. Well, to bring it full circle, if you're building serverless for edge environments and you're building containers for edge environments, what is that like? What is your tooling like, and what is your lifecycle like? Serverless, you don't have to worry as much about processor architectures. Containers, you do. That's something that's always on my mind, right? Someone's building on a Windows laptop and they know they're going to run their container on a variety of devices, or they know they're going to run it on like a Raspberry Pi, right? And now you got to have a Raspberry Pi nearby, or you got to use the QEMU, right, to cross compile and build a container for the other. And no guarantees it's going to work, right? I've definitely run into snags. Dan, I'm trying to bring it back to flesh out some of your points and give you some material here for this.
Perfect. Do you think that this is like one of the points why they never support C++ and C and all this stuff in serverless?
Oh, maybe, right? Because you can't. It's not compiled, right? Or it's not. Sorry, interpreted, right? It's compiled, not interpreted, and then could be.
But for
right?
example, here they use Golang and .NET. I'm not quite sure if this is compiled, but I know Golang or Go is compiled as well. How do they handle that actually? Like, do they compile it first and then?
Yeah, I don't know. That's actually a really good question, because I totally understand how they do Node.js and Python and all of this. It's a piece of cake, right? But that's worth understanding and looking into. Yeah.
If I'm not mistaken, I think the OpenWhisk serverless does support C++.
Ooh,
I'm not
cool.
sure which of the other ones do, but I think I've seen that one does.
Don't you run like into nasty runtime problems because like an int is not the same on every machine because it depends on the architecture you're running on, for example?
Yeah, I mean, I
I think
imagine
you
that comes
would potentially, yeah.
yeah, I imagine that comes up a lot because it certainly comes up with containers, where if you're going to, tap into something for computer vision, OpenCV on the host,
Yeah.
and it's not built properly on the host for, whatever you're trying to do, then either your container is going to take about 2 hours to build, and then it's going to be huge, which I've done that, right, to make it force it in and make it work, or you just can't run on that board, and that stuff happens. Well, a lot more with less C++ related things, but computer vision is, people use Python to use the computer vision, but Python does not do the OpenCV operations. That's plus, yeah.
Same with TensorFlow, basically.
Right, yeah, exactly. Your usage of it is flexible, but the engine is not. Yeah. Okay, Steve, so you posted OpenWhisk. All right, cool. I'm learning a lot here, and this is really great.
Yeah, I think there's OpenWhisk, OpenFast, Knative, and Knative, I think potentially there's degrees of how opinionated they are. So I believe Knative is going to demand Istio along with it, which, for an edge application that might start, the more things that come along for the ride, the more potential venues you might run into that don't have the resource to do it. I think a big flavor of these where they differ too on these platforms is what kind of wiring assumptions are built into how to drive these from commonly found event streams so that you can put them in place to be completely event driven rather than called at all programmatically. You might have these things just triggered from streams from, message queue based things.
I think, yeah, the Knative and the cloud events are trying to solve that, at least for the Knative. I know that they put a lot of work to define the spec for the events and then do the mappings to different protocols and things like that, so that you can run it over anything.
But it sounds like
based.
the whole topic of serverless at edge would be actually a great subject. We'd need a long runway to get ready for it because it sounds like we have no experts on the call, but maybe there's no experts in the world. And if we would plan this for some KubeCon later in the year.
Everything gets planned around a KubeCon. Sure.
Well, you want to get people, if you're going to bother to do it, you want people to show up, and
Right.
What conferences are going to give you a big audience?
So what would be, so then we've got China, right, would be after March, but before
I think
the fall?
China might be June, July. I'm not sure, but I'm sure it's published. And then
I think it's July. I saw
North
the
America is in Boston in November,
November.
December, I think.
I'm definitely down for figuring that out, and or finding the experts and having them help us figure it out if they're out there.
Same here.
Cool. We'd like to increase our club size.
Especially on the European time schedule, right?
Hey, this time slot is getting good.
Getting crowded.
Yeah, this one actually, I think, got more attraction than the US time slot. I mean, it's at night. I don't have other meeting.
There is something to be said for that.
Mm.
Well, the interesting thing I found is that some of these things that start with no agenda at all seem to evolve into fascinating conversations somehow.
This time slot is the R&D arm of the Kubernetes IoT Edge working group.
It's getting
I have
on
not picked up on
at
it
6 a.m., but
any of the
it
video, but maybe
always.
there's people who have a beverage in hand of some sort that encourages the discussion.
Cheers on that.
Yeah, for Moritz and me, it's 6 a.m. and yeah, but it's usually end up being very satisfying session. Like the night before, you're thinking, it's 6 a.m. tomorrow. Why? And then you end up in a good place after the call.
If I had to get up at 6 a.m., I don't know. I think I'd have to leave the video off because
Yeah, it's much appreciated, guys. Right? Not just coming on, but being so lively.
Yeah, coffee helps basically.
well, you need to move.
Cool. It's about time.
Yes,
Yeah,
so
we got 3 minutes left. Anybody have any last minute?
but it's good. We have a couple of things to push on, right? So that's
Yeah, well, I think we've come up with a lot of problems in the world and haven't moved on to the solutions yet.
Moritz's paper's got solutions in it.
yeah.
Well, I think it has options. It doesn't give you the exact flow chart of if you have this, you need to do that.
That'll be next year's paper then, right?
Yeah.
Which one to choose and why.
The salami tactic, always go in slices.
So, never heard it called that, but that sounds like a good approach.
All right.
All right.
Okay, well, good talking to all of you.
Yeah.
And
See you all on
catch
Slack.
you,
Bye.
2 weeks for the North America one then.
Yep.
Sounds good.
Yeah.
You guys in 2 weeks.
Yeah.
Take care, everyone.
Good night.
See ya.
Bye bye.